Hello guys. So today we will see about what are lambda functions in C++. So lambda functions are basically unnamed functions or anonymous functions. So unnamed functions means so it's similar to normal function but without names. So that means how function can be without names. So let's see an example. So this main is a function. So now I am creating a lambda. So this is a lambda. So here we are passing parameters of the function, and here inside we can return something like a normal function, and here we can write the body of the lambda. So these are functions without a name or anonymous functions. So this is introduced in C++11. So before that, before C++11, lambda functions are not there. So why these lambda functions are introduced? So these are mainly introduced to replace function pointers. So function pointers and function objects. So the function pointers and function objects we used to have before C++11. So after C++11, mainly these two are replaced by lambda functions. So is it, if you ask, so after C++11 we don't use function pointers or function objects? No, it's not like that. Only in certain cases the function pointers are replaced with lambda, and in certain cases function objects are replaced with lambda. So in many other cases, still the function pointers are used, function objects are used. Okay, so let's see what is function pointers and function objects. So function pointer is nothing but a function point. It's the address of a function. So nothing but address of the function. So function pointer is the pointer which refers to the address of any function. Okay, similar to the normal pointer, like if we have int pointer, it will point to integer variable address, right? So similar to that, the function pointer is nothing but a pointer that like refers to another function. Okay, so where this function pointers are used? So mainly it is used in like a callbacks. So when we have any callbacks to be executed, so that time we will be using this function pointers. So nowadays, like many callbacks are replaced by this lambdas. Okay, and what is function pointer? Sorry, what is function objects? These function objects are nothing but, so function objects are function operator call. Function operator call on an object. So function operator call on an object is, so let me explain what is that. So this is where this is usually this is mainly used in STL algorithms. So mainly using STLs only it will be used. So function objects. So some may also say functors. So it is also named as functors. So this lambda is mainly replacing these functors and function pointers. So let's see what is a functor. So functor is nothing but a uh, function call operator on an object. So if we have any like sort algorithm, like we have a vector. So we have vector. So if we want to sort it, what we will use? We'll use algorithm. This sort is part of algorithm header file. So hash include vector and hash include algorithm. So the sort is part of algorithm. So what you will use is v dot begin and v dot end. So here, what it will do is it will sort the vector based on ascending order. This is basic data type. So it will have its own sort function inside this sort. That is ascending order. It will sort according to that. If we want to have it in descending order, what we need to do? We need to pass the functor here. So now let's take another example. So not sort. We will take transform example. Okay, that will be easy to understand now. So now what we need to do is we need to pass the functor object here. So what it should do is it should convert all vector in V, store it to V2, okay, and multiply it by 10. So that is the goal. So how we can use it is V2 dot begin. So this is the syntax, and here we need to we need to pass functor. So let's say what is functor. Functor is nothing but logic which we need inside STL algorithm, but how it need to be used, it need to be encapsulated inside like operator call function. So operator call function is nothing but operator. Okay, so this is operator call. Okay, so operator call is, see, this is operator call operator. Okay, sorry, this is a function call operator. Okay, so I am overloading this function call operator as function. Okay, so that's why operator this open parenthesis, and this is normal function. Here we need to pass parameters. This open close bracket is operator. Okay, so here what I need to do, like I need to get each element. So this transform will iterate through each element on the vector and pass it to this functor. So it need to take one value and I need to transform. So how I transform? I need to multiply each by 10. So I am returning n into 10. Okay. So I need to encapsulate this logic inside function call operator. But here I need to pass functor. So functor is nothing but function object. So if I need to pass an object, I can't directly pass this. I need to encapsulate inside uh, what inside a class. So that's why I'm creating inside a class. So this is nothing but encapsulating this logic inside class. I need to make it as public. Okay, so now I need to create an object here. So multiplier m. Okay, so I have created an object here. So here I need to pass m. So let's see what is the output. in v2 cout I. Okay. Okay. Identity std namespace. I'm going to run this. So if you see 10, 20, 30. So this is function object of functor. So functor is nothing but function operator call. So inside this, how it will be called is like this. It will be called for each element. So each element will be passed like this. So each element in vector will be passed like this. So a functor is nothing but an object which is called like a function. So if you see m, if you so it will inside this transform, it will be this functor will be called like this. So this is nothing but an object, but it is called like a function. So that's why it is called function object or functor. So if you see for the simple transform, we need to write so many code like uh, we need to encapsulate inside a class and we need to overload this function call operator. Everything like it looks complex, right? It's not obvious. So that's why now how like uh, we have introduced the lambda. Let's see what how the lambda resolves the same problem now. So I already have shown you the lambda syntax. So this is the lambda syntax I already shown you. This is the capture class, this is parameter list, and this is body of the function. So uh, so capture class we will see later. What is capture class? It is nothing but it will capture the uh, uh, like variables, say like within it, like in the scope within its environment it can capture. So I will explain it later. Before that, the same function I have written without a name. So if you see, this function is used only in this transform, but we have created a separate class. So it looks like this is unnecessary, right? For single thing, we are creating a class and overloading operator, like this function call operator. So it is complex and more code, and it's not easily understandable code. So that's why I have like replaced this with lambda. So let's see what is output now. So if you see, same output is there, and here we have very less code, and it is very obvious and easy to understand. So if you see some so an um, parameter we are getting, and it is multiplied with 10. So and we are using here inside this transform itself we are using, because here only we needed, we are directly used here. So this is a so that's why nowadays lambdas are replaced with functors. But if you say for all cases is it the same? No, only for simple cases we are replacing. But if we have very complex logic, then we have to go with functors only. But for very simple things, we don't need to write a separate class and use it. Instead, we can go with this lambda. So this is lambda. So I hope you have understood. So in next video, we will see lambdas in detail. And similarly, previously we have used function pointers. If you see the syntax of function pointer, it will be somewhat complex. We can't understand by just seeing it. So there also we are replacing lambdas with these function pointers. So that's it, guys. This is an introduction about lambda. Thank you.